All right, so this is working out equations with square root inside of it. So just the basic one is square root of x equals 7. So this is asking, okay, what number do I take the square root of to get 7? And most of y'all can tell me the answer on that one, right? 49. So x is 49 here. Okay, but algebraically, how do we do that? What happens here is the square and the square root and the square actually cancel each other out. So if I square both sides, the square and the square root will cancel out, and then 7 squared gives me 49, and that will give me my answer. The reason that works is because, do you remember, how could I rewrite the square root of x to what exponent is that? The square root. What exponent is the same thing? It means the same thing as square root.
Exponent. 1/2.
Exponent, 1/2, right. So x to the 1/2. So what happens here is if I have x to the 1/2, which is the square root, equals 7, what I'm really doing when I square both sides is the square and the 1/2 cancel each other out, and I just get x equals, got to square both sides, 49. But that's why the square and the square root cancel out. But basically all you're looking at here is the square root of what number equals that number. And to get rid of the square root, you get the square root by itself, first of all. And to get rid of the square root, you square both sides. The square and the square root will cancel each other out, and you get x equals 121. So the square root of 121 is 11. If you have other operations inside of the square root, that's fine. So here I have the square root by itself. So to get rid of the square root, again, I square both sides. So the square and the square root cancel each other out, and I get x plus 7, what's underneath the square root, equals 4 squared, which is 16. And now to solve for x, I just subtract 7. Whoops, 2 equals sign that. Subtract 7 from both sides, and x equals 9. The first thing, I said this, but we have another problem I get. The first thing you do have to do is get the square root by itself. So you need to get the square root completely by itself, get everything else on the other side. So here I need to get rid of the 5 before I think about squaring it. So I add 5 to both sides. Now I have the square root of x plus 2 equals 8. Now that the square root is by itself, now I can square both sides. The square and the square root will cancel out. And you get x plus 2 equals 64.
How come you don't square the 2 just the first one on the left? Like square root of x plus 2.
Right here?
Yeah.
Because that's underneath the radical. So the only thing that's being squared here is the radical, really. So like if I had x plus 2 to the 1/2, and then I'm squaring that, so the square and the square root cancel out, it doesn't make it all the way into there. Does that make sense? So now subtract 2 from both sides, and you get x equals 62. Like the x on these problems up here, the x isn't being squared either, so the square just cancels out the square root. What about this one before you start working it out? Can I do the square root of something and get a negative number? I can't do the square root of something and get a negative number ever, so this one is actually no solution. So anytime you have a problem, I believe there's one in the homework that's kind of like this. Anytime you have a problem here, so I got to get the square root by itself first, so I subtract 8 over. So the square root of x plus 8 equals negative 4. Well, the square root of no number will equal negative 4, so this one is no solution. we're not talking about this section, but just to show you, we'll talk about it next section. So the opposite of that, just like if we had x, 2x equals 4, so this is 2 times x, we divide by 2, you get x equals 2, right? So the opposite of that would be, if I had x divided by 3 equals 5, x divided by 3, the opposite, you would multiply both sides by 3, right? And get x equals 15. So just like this one, if I had x squared equals 49, what were you thinking, Max?
I was going to ask, like, would you, for the above equation, would you have a cube root or something?
Oh, we need to do cube root, yeah. I'll do that in a second. I forgot about that. X squared equals 49. So here, well, the square cancels out the square root, so just vice versa, the square root is going to cancel out the square. So if I did the square root of this, the square and the square root cancel out, and I get x equals square root of 49 is 7. So we'll talk about that next section, but since it kind of goes together, the square and the square root always cancel each other out in the equation. There is one trick to this one that we'll, again, talk about more next time. But 7 squared equals 49. There's actually another number squared that equals 49. What? -7, right? -7 times -7 also equals 49. So when you do the square root inside equation, you do this little sign called plus or minus to account for both of those, because 7 squared equals 49, which is +7, and -7 equals 49, which is -7. So this is two different answers. It's -7 and +7, but we just write it like that.
What do they require us to write that in?
They do not have a plus or minus button in my math lab, I don't think, so I think you got to do -7 and +7. It's two different answers. But everywhere else, you can just use a plus or minus. And again, we'll talk more about that next section. It goes along with this. The square and the square root cancel each other out in equation. So. All right, so you asked about cube root. What about, all right, so the cube root of what number gives me 3? So that means the cube root of what number gives me 3? 27, correct. So what you do here, if the square cancels out the square root, then cubing it cancels out the cube root. So you get x equals 27. Or if you had one like, so here, to get rid of the cube root, you just cube both sides. The cube and the cube root cancel out, so you have x plus 5 equals 8. Subtract 5 from both sides, and x is equal to 3. Or even if you had the 4th root of something. So to get rid of the 4th root, you just take it to the 4th power. 4 and the 4th root cancel out, so you have x plus 2. 3 to the 4th power is what? It is 81. Subtract 2 from both sides, and x is 79. All right, so this one, 2x minus 4. So first thing you want to do is get the cube root by itself. So you add 3 to both sides. Now the cube root of 2x minus 4 equals -2. So now to get rid of the cube root, I have to cube both sides. Well, wait, I have a negative over here. Is that okay? It's okay because it's a cube root. It's an odd number. So you have 2x minus 4 equals -8. And then add 4 to both sides. You get 2x equals -4 and divide by 2. So x equals -2.
So that answer could be negative.
Well, wait, your answer could be negative. your answer could be a negative no matter what. Okay. You just can't have, let me go back and think of a problem here that explains that. So I have the square root of x plus 20 equals 4. So when we work this one out, right, we square both sides. So we get square and square root cancel out. So I get x plus 20 equals 16. So now if I subtract 20 from both sides, I get x equals -4. So think about if you plug that back in. -4 plus 20, does that equal negative, or does that equal 4? So -4 plus 20 would be 16. The square root of 16 is 4. So that works. So your answer can be negative. What can't be negative is when you have the square root of a number equals a negative number right here. Because I know the square root will never equal a negative number. But you see how this one is positive right here? So that'd be fine. The square root of a number will never equal a negative number.